Before we just commence, I'll just introduce myself. I am Anoop Naik. I am having around 30 years of experience in project and operation management, and HSE has been an integral part of my journey. So, if you look at technological advancement, what we are looking today is traditionally we started with having human intelligence as well as culture development of the people. But as the technologies are now improving, we should also look at how the HSC can be improved, enhanced using the technologies. So what I could see is in three areas. One is today AI driven, you can say risk prediction is one area where we can look at improving the enhancing our safety culture. The other one is on the you can say IoT based sensors. So real time you can look at how the sensors can give us data so that we can monitor some of the alarms which will help us mitigate the risk or identify the hazards. The third one is VR based training as well as on the you can say smart PPs. So what we can see today is one of the reason for incidents is not having good trainings and also the awarenesses, and also on how we can make use of the technology in terms of PPEs. There are certain technologies which talks about the fall alerts can be generated, the fatigues alerts can be generated, which will help us improve the safety or enhance the safety. So that is just a small takeaway from my side as how we can use the technology. As we go in this session, we already have some used cases. All the panelists, all the speakers who are here are having their own expertise in various technologies, which either they have used in their own organization or they have advised for using to others as vendors. So we'll just go through what all they have in terms of technologies which will help us advance or enhance HSC in this world and keep our people safe. Okay, so I'll just start with the first presentation. Mr. Ashish Gohil, he is General Manager in Pipeline Infrastructure Limited. He has around 15 years of professional experience in HSSE. I request Ashish to please take on with his presentation.
Yeah, good morning all. Thank you, Anoop sir. Yeah, it's a privilege to me to be here and present the digitization journey by PIL. My name is Ashish Gohil. I am working in HSSE department in Pipeline Infrastructure Limited. So about PIL, Pipeline Infrastructure Limited is having having 48-inch pipeline from starting from Kakinada, Andhra Pradesh to Bharuch, Gujarat. It's 48-inch diameter pipeline, which is supplying natural gas to big industries as well as CGD industries. Right. So this is India's first bidirectional pipeline. So this is about Pipeline Infrastructure Limited. Yeah. So normally HSSE is the key critical role in our day-to-day life as well as oil and gas industries, right? So, but however, you can see some scenario in the morning in our offices, right? One maintenance person has planned some corrective or preventive maintenance. He is looking for some work permit. He is searching for some forms, some checklist. He is asking his supervisor to provide yesterday's permit so that they can close the permit. One person is preparing some MIS from different spreadsheets. So these are the day-to-day scenario. So at PIL, we were also having some issues like we have our own developed application, and we were also generating so many records, but it was not there in any single platform, right? So if you need to prepare, like if your boss is telling you that just give me last 3 years incident data with root cause analysis, what are the key challenges, key issues in our organization, then we have to search for different spreadsheets, different emails, different applications. So what at PIL we decided to make one integrated platform for the critical applications like permit to work, management of change, then HSSE reporting, incident management. So all this application can be integrated with each other. So I'll brief about that. Yeah. So to make this integrated platform, it was not decided entirely by HSSE team or any single team. PIL has formed 18 members of team consisting of HSSE, IT, technical, HR. So why this team was formed? Because we need to make this system user friendly, not means as directed by HSSE, right? So this team was formed, and then we identified one basic service provider who can provide one integrated platform. We already have one ERP software, SAP we are using. So we need to integrate that also into our HSSE software. So there are key, if you say key application or key jobs related to HSSE are permit to work. So what we have make platform where person can use same application for permit to work, for incident management and any kind of reporting. And it can also be operated through mobile phone also. They don't need to rely on any desktop or laptop, right? So you can see our file system. In the right side, you can see one to-do list. So this is one of the favorite thing of everyone. Whenever you open your application, you will find whatever task is pending against you, right? Whether it is related to permit to work, whether it is related to MOC, whether any action is pending from your side, any mock drill action is pending from your side. Once you click, you will get all the data that this is my to-do list and this is the target date for completion. So this is one of the major thing. Now, we have entire workflow for permit to work. These are just the major key things which we have customized and developed. So normally you can see every person who is requesting any work permit, they need to collect so many data like functional location, equipment ID, scope of work, what work description is there. So what we did, we integrated entire thing with our ERP platform. So you can see with one click, all the data related to any breakdown maintenance or any preventive maintenance, we will get it auto-filled to our permit to work module. So it can be done through single click. So user will get all the data, get it pre-filled in the permit to work page. Then we also have mandatory GPS tagging. Means while applying the permit, there is mandatory selection of their coordinates, so that we can also verify that person is doing the work from site only, not from any office or from other side, right? Then there is also mandatory option of live uploads of site photos. So this is also mandatory, that without, means we do not have any option to upload any photos from gallery or anything. Person has to be at site. They has to submit the photo through online mode only. Then there are control extensions, like we still have manual job safety plan. So that is because it's human interference is required in job safety plan. So we have made it manual, but without uploading the JSP, permit cannot be submitted. So that customization is also done from our side. Now, we also have online checklist for all the activities, like if I have to do some welding work or I have to do any work related to work at height, then I don't need to fill any hard copies. We already have the real-time checklist filling on that application only with that permit. If I select work at height, then mandatory checklist will be popped up and they have to fill it. So that is also a part of that permit. And during closure also, there is a mandatory closure attachment with site photo that all the mandatory documents like LEL checking and any other fitness certificate with the closure site evidence, that photo is also mandatory. So this is related to enter. So we have a lot of other customization also, but due to time constraint, I have taken some key aspects. Yeah, and as we are into the natural gas business, we have provided all person with IS tablets, which can be used in hazardous areas. So now HSSE reporting. Any reporting related to unsafe act, unsafe condition, any near miss, any other fire incident, any leakage incident. So these things we have made mandatory. Like first thing person is having in his mind that how to do, if they observed anything, then how to do reporting. What are the ways to report, right? So there are two things. One is person is not having, if it is online application, then all persons are not having the login ID and password, right? So what we did, we make one QR code also. So by just scanning the QR code, they can report. And we also have that functionality that any person can anonymously also can report anything. So this thing is also there. Some person may fear to report any unsafe act within that organization. So that also means through this QR code, employee can also report, as well as any contractor person or any third party, any visitor can also report any unsafe without giving any name. Right. Second issue is language issue, or means person maybe not familiar with in writing in English, or so we'll also have one function, means through their voice they can also, means they can record the voice, like if they are, if in Hindi, means they can also get yahan pe pani gira hua, it's a slippery surface. So through that voice report also they can attach with the report. So simply means we will get the report through multiple ways. Then we also have AI driven assistance, like some employees is filling anything or reporting any unsafe act or any incident. So you can see if he mentioned that person is slip in this area. So we have AI assistants, they will means suggest them, this is not the full description, you may also mention this thing, like at what time, at which place. So they will not stop them to report, but they will suggest. So ultimately, the person who is reviewing the report, they can means get proper idea of what has happened, right? So this AI-driven assistance is also there. One feature is their photo to text. Like this is also one of the things, like if any person is capturing any photo, then through AI, it will describe the entire photo. Like if you see in this photograph, one pipeline is corroded, right? So you can see there are a lot of suggestions. There is a corrosion on the pipeline. Pipeline is on the ground. It is having a slip and trip hazard. So these are the things that through this photograph and this wording also person can visualize what is the hazard in this. Now, after getting any report, we have incident management module. So what we made mandatory, like any report from starting from near miss to any incident, any injury incident, any fire incident, we have made it mandatory. So if it is reported, then it is a mandatory escalation that we need to make the investigation team, and root cause needs to be identified, because we believe that if we control our near miss also, then we can avoid any major incident. So it is also made mandatory. We have inbuilt 5I analysis. So yeah. So I'll go quickly. So we have inbuilt 5I analysis, or through this root cause also, with one click, we can analyze last 3 years data also. What are the major root cause we have due to the incident happened in past. So I'll go quickly. So we also have one module on management of change. Earlier, we were also having in-house developed application, but there are some flow which were approved on email or other form. So we have made this management of change module entirely online, and all these stages will be assigned to the respective person, and based on their filling of required checklist or screening, it will move to approve. So if you see technical review, execution, PSSR, everything is there in the management of change module. And we have our own inbuilt tracker of MOC. So yeah, one more thing related to MOC, if we find any point in between the MOC review and during the PSSR, if any point is assigned to any person and it is marked as critical, then this permit cannot be commissioned. Means that activity cannot be commissioned without completing those tasks. Yes, this is also one of the main module of our system, action tracking system. So we have seen there are a lot of things like mock drills, incident investigation, HSSE reporting, any audit, senior management visit. There are a lot of things is being tracked through different applications. But what we have developed, we have made ATS as one platform. All the actions will be assigned in this platform only, and any closure should be verified by the SME. So that system is also there. So person do not need to go for different site or different email. They can check their action through that system only. So there are also suggestive AI. Means any action is reported, then AI will also suggest these are the things where you can take the remedial measure, preventive measure. So this is also suggestive. Yes, and we made customized dashboard. So any person can customize for themselves, means what they need to track. So this through this dashboard they can. Yeah, so there are so good, we implemented this 1 year back. So we got very good result, like increase of reporting, transparent dashboard, stronger follow-ups, higher engagement, operation efficiency, and smarter reporting. Yeah, thank you. And yes, one more thing, digital tools support decision, but critical safety action requires human judgment. That's it. Thank you.
Digital transformation can bring power in our enhancing safety, where they were able to bring all the processes together where permit to work, manage of change, and interlink them, and that data can be used for future analytics, which is future AI, right? So AI can be built only when data comes in a digital form. So that is what we can learn from use case, what they have done at Pipeline Infrastructure Limited. Thank you, Ashish. We'll go with the next presentation. Vimal Kumar from BPCL is DGM maintenance, having around 23 years of experience in oil and gas. I welcome you to present your case study.
Very fine. Good morning to all delegates and my fellow speakers. So as we move across this IEW exhibition hall, you can see 3 tags: energizing growth, securing economics, and enriching lives. So for me, I believe that these are all not taglines, these are all responsibilities. The growth will not happen only by the numbers, it will happen through the safety of the people who achieve that growth. So to truly set for ensuring lives, we should begin with ensuring lives, like the person who is entering a refinery, who should be safer, healthier, and more protected when he is going back. So this topic is one of those. So today I am here to talk about laser cleaning, a safe alternative for shot blasting, an initiative closely aligned with BPCL's strong commitment on safety, sustainability, and technological innovations. As we all know, there are 2 pictures. One on the left is our traditional shot blasting, and another is a laser cleaning. So as we all know that shot blasting is used to clean the metal surfaces to remove the rust and dust so that painting and other entity services can be done on it. But as you see, the person who is working on a shot blasting environment is full of dust because shot blasting is done through fine metal particles or sand which is propelled at a very high velocity which will hit on the metal to remove the dust and rust. So at the end of it, the person who enters with a fair uniform will come as a black out of this shed. So shot blasting is only for to clean the metals, not to make the operator black. So if the dust is going to win, we should change that story. So this made us to think for a alternative technology through which we can ensure safety of the operator. That is the laser cleaning. The same process which was done on the left-hand side is done on the right-hand side picture, where you see there is no dust, no noise, and the operator is safely conducting this shot blasting. So as we know, there are health hazards of shot blasting. One is dust exposure. Since we are propelling the metal solids, fine particles on the metal, lot amount of dust is created. As we all know, this silica can cause silicosis and lung cancer and breath-related diseases to the operator over a long term. And some abrasive materials contains lead, arsenic, and beryllium, which when inhaled will induce you to a carcinogenic agents and it will cause irrecoverable disease to you. Moreover, these metal particles, which when hit on the metal, generates large amount of noise, not only on the propelled material, but also on compressor, which is used for this propelling. This heavy amount of noise is created during this process. So even though the operator who is doing the shot blasting wears all the PPEs, over a period of time, due to the congested environment, he slips some of the PPEs, and this noise pollution will incur him extensive hearing loss over a period of time. And at the end of it, once the shot blasting is over, you will left over with lot amount of abrasive materials for which the waste disposal is a big problem. So even though you collect the waste, once the disposal is a problem, when it goes to the nearby water bodies and soil, the soil will also get disturbed. And another hazard in it is, since we are propelling the particles at a very high speed, the silica particles may get rebound after hitting the surface, and it can cause severe cuts and eye injuries to the operators. So it is time for us to do a alternative for this. So this is what laser cleaning is. A laser cleaning, we use a focused beam of laser on a metal contaminant where the rust and paint coatings are there. It operates on the principle of laser ablation, in which extremely fast, short, and high energy light pulses are delivered to the surface. So what happens? These laser particles will burn the dust and contaminants above the metal particles, and once it is created, the amount of energy we give input is such that the ablation resistance of the base metal will be high, so that it will not affect the base material where the rust is there. So after this, due to the buoyant pressure which is created, the contaminants or the rust will get removed from the surface. So this is what the laser cleaning does. So once we go through laser ablations, it consists of a laser beam is directed on the metal surface, and the rust and contaminants will absorb the energy and it will get vaporized. And once it is vaporized, it is removed from this. So you will be surprised that if you are focusing a laser on a material, whether your base material will also get affected. But that will not happen because each material has a different ablation resistance. For example, if an ablation resistance of rust and paint is 0.5 joule per centimeter square, but ablation resistance of our base metal steel will be 5 times more. So you adjust the energy of the laser such that it removes only the dust and it will not affect the base material. So what we have done in Kochi refinery is one of the refineries of BPCL. We had done this trial on the material for which shot blasting is required on a pipe and a structure material. And we can see the environment in which the operator is doing this shot blasting. See, the operator is just wearing a laser goggles to protect his eye, and the person who is standing nearby has not felt that some dust is being removed from the pipe. So in case of a traditional shot blasting, if you are doing a shot blasting on this open environment, no person can stand near to that. And moreover, the noise level is very minimum, so that you can do parallel works along with this during a shot blast, during a laser cleaning process. So this will be very useful during turnarounds of a refinery, which is taken once in 4 years. So where multiple parallel activities has to be undertaken to complete the job within a 20 or 25 day schedule. So if you do a shot blasting on an open end plant, the nearby works will get affected. So this laser blasting will be very useful during that process. And moreover, after what we have observed is, there are two types of laser technologies. One is continuous laser and another is pulse type laser. So in a continuous laser is the one you have to continuously apply the laser. It will take a lot amount of time to remove the dust. But in case of pulse laser, it is a short-term pulse is impacted on the material so that the rust will get evaporated. So what we have found is, after this laser blasting is done, the operator can touch the material, touch the workpiece and take it to the next place. That means it is like an induction cooker what we use. Only the content which is inside the vessel is getting heated, not the vessel is not heated. So we can touch the vessel. The same case happened here. The operator can take this metal and shift it with his hand itself. So this itself will indicate that it is not affecting the integrity of the base material. So now, what are the advantages? It's obvious. No abrasives are required for doing a laser cleaning. And since no abrasives are required, so no waste material is generated during the process. And it is very precise. So it is non-contact and highly controllable. So since it is very precise, that it will be very useful for cleaning turbo machinery spares like rotors and stators, where close clearances play a major role in the smooth running of the machines. So normally during a turnaround, when the compressors and machines, turbines are opened, the rotors and stators are shifted from the compressor platform to a shot blasting yard, where it is shot blasted and it returned back. So while transportation, there is a chances of damages on the blade tips, which will be like an aerofoil type, which you can see in the aircraft. If you have some dent or damages on the tip of the blade, that will affect the performance of the machines. So by doing laser cleaning, that is get removed. So while doing this cleaning on one side, you can do the other parts of overhauling on the side by side due to this zero emission properties of the laser cleaning. And it is an enhanced safety. So it requires laser goggles to be used. It eliminates airborne and noise pollutions. And the environment benefit is very clear that once it is through, there is no waste material generated out of this. And next is, if you compare the laser cleaning, it is obviously non-contact, no damage to the base material. It is highly precise, no consumables required. Waste generation is very minimal, and the goggles is the one which you use for a PPE. And the cleaning speed when compared to traditional shot blasting is slower, but it requires high capital investment of purchasing the laser machine. So there are, for every new technology when we introduce, there may be challenges which will be overcome over a period of time. The first challenge is high capital cost. The laser cleaning machine will have to procure a laser machine which will be of high capital intense cost item. So this can be justified. For example, if you are doing a safety project, we will not calculate IRR for that, because safety is first and safety is must. So since it is related to the safety of a person who is working in an environment, the high capital cost once invested is worth while investing for a safety prone area. Next is slow processing speed. As you know, the traditional shot blasting will be faster. You can cover vast area over a period of time. But this process is little bit slower. But over a period of time, the operator will gain his own experience and his speed can be increased. And it requires power. Once it requires power to start. And the other constraint is laser, it can access only the direct inline side, because the laser has to penetrate and touch the surface. So if you have a complicated surface where you have multiple curves, there this laser cleaning is somewhat difficult. But in case of shot blasting, that will go to the intricate gaps and it'll clean. So now, what are the key takeaways is it is a sustainable alternative, dust-free, noise-free, environmentally sustainable alternative for traditional methods. It is highly precise. As I earlier told, it will be since it is highly precise and it won't damage the base material, it will be used for crucial turbomachinery critical maintenance activities. And in BPCL KR, we had validated this process and we had trialed on multiple cases, from which we got confident that this material, this technology can be used across many cleaning process across the refinery day-to-day maintenance activities. So some of the recommendations are selective adoption of laser cleaning requires precision cleaning, its minimal substrate is impact, and for NDT surfaces and turbomachinery components. And to improve, even though the laser cleaning, as I told, is safer, to increase its safety systems, like you can integrate with a fume extraction and a VOC filtration system so that whatever small amount of fumes which are generated during the laser cleaning will get sucked by the system and the operator will be completely free. And what we can do, since it is a new technology, we should conduct pilot trials on different types of contaminants of different thickness and how much energy and how much power is to be adjusted to clean the surface. So through multiple pilot trials, we will be able to get a database for how to clean different substance with the different types of contamination. And its enhanced health safety benefits is exposure to dust and noise is almost removed. So this is about laser cleaning. I think this will emerge as the latest technology for traditional shot blasting. Thank you.
Thank you, Vimal. You can just hold for a minute since there is 2 minutes available. See, one thing I could just see while he was talking about laser technology, I still remember a decade back, there used to be comparison between sand blasting and shot blasting. We started with sand blasting.
Yes.
Technology changed to shot and grid blasting.
Yes.
And now we are moving to laser. So this is how we keep improvising and enhancing safety. So can you just talk about who is the vendor you have used for this?
The laser cleaning, most of the machines are from China. And we have Indian vendors who import this machine, like Netaflex is one vendor who is based in Tamil Nadu. Okay. So through that vendor, we had done a demo. There are multiple vendors who can import these machines on a larger scale.
Okay. And you have confirmed that in the testings, the original homogeneity of material is not disrupted.
Original material.
Those tests you have conducted.
Yes, sir.
Thank you. Anybody has got one question, since we can take it? Okay, thank you very much. Yeah. Sourav Mukherjee, Senior Manager at Engineers India Limited, is having around 14 years of experience in design and construction and commissioning. Please carry on with the presentation.
Good morning, everyone. We all know that safety is of paramount importance, especially when we talk about oil and gas industry. So can we utilize or leverage the power of AI to enhance the safety of such oil and gas complexes? The answer to this question is yes. Myself, Sourav from Engineers India Limited, and this is my submission on the same. In this presentation, we will have a brief overview of the system which we have implemented. We will see the hardware and the software which we have deployed to realize this solution. We will see digital handshaking between various stakeholders who are involved, say the customer, the contractors, etc. And with that, we will see the salient features, and in that we will conclude this presentation. Leveraging AI for transition, HSE governance from reactive compliance to proactive safety interventions. So here we are leveraging the power of three very critical facets of digital technology. One is wireless surveillance, second is video analytics, and third is cloud-hosted digital reporting. Using these three, we are trying to implement a digital safety system which acts as a single source of truth for the entire project. It's a highly scalable system, very readily deployable for large-scale industrial environment. The system works on 4 pillars. Pillar 1 is detection, where we are using cameras for detecting safety violations. The feed from the camera is worked upon by an analytics, where an AI engine analyzes the camera feed to identify safety violations. Then we go to hosting. Here we are using a cloud hosted infrastructure where the safety violation videos and photos are hosted over a internet cloud. And over the cloud itself rests the reporting mechanism which ensures stakeholder specific dashboards through which we have got workstations and apps using which various stakeholders like customers, contractors, etc. interact digitally to realize the safety system. We will follow a very simple methodology in this presentation. First of all, we will see the HSE violation use cases which we have considered for this project. I guess we all realize that whenever we are talking about AI, the use cases basically define the boundaries on which an AI engine is going to work. So we are going to look into that. Then we will see the hardware and the server systems, basically how we capture the data from the field and actually bring it to a central location so that we can deploy the AI algorithms on that. We will look into the salient features of the AI engine and how we can optimize that. And finally, we will see the digital integration amongst various stakeholders to conclude the presentation. So here are a few very critical HSE violation use cases which we have identified and realized to this project. They are PP violation, unsafe height work, we have entry in restricted area, we have got fire detection, we have got fall detection, we have got no motion detection, and we have got camera tampering. These have been identified after extensive discussion with our construction counterparts to determine the boundary of our AI algorithm. Some salient features of the overall system has been captured here. First of all, here we have gone for 3 megapixel bullet cameras, and we have also gone for PTZ cameras. So for areas like pipe racks and tech structures which are cluttered areas where you don't have a very good clear line of sight, there we are using bullet cameras. We are also using PTZ cameras on high mast for areas where you have got a wide, where you have got a scope to capture a wide view. Then we have gone for a completely wireless infrastructure. All our cameras are wireless because we are deploying this solution at the construction phase of the project also. So we do not want any kind of a video feed loss due to cut-in cables. All the installations are temporary. In that way, we are realizing the benefit of optimization because, say for example, construction work in any particular area is complete. Then you don't have to keep the cameras there. You can open those cameras, relocate it to those areas where more construction work is going on. In that way, you can use your hardware better. For we all know that oil and gas industry has hazardous area. So we have also taken hazardous area camera and hazardous area infrastructure catering to those areas. And the solution is suitable for the construction power because since the deployment is across vast areas stretching across the complexes, it is not possible to provide UPS power everywhere. Some more silent features are listed here. I will touch upon the most important. Here we have used both omnidirectional and sectoral antennas to cater to the camera data. This is important because, say, now imagine a plot, for example, a rectangular plot. All your cameras are located inside the plot and you want to capture that camera feed from one particular angle, say from the corner. For those cases, you will use sectoral antennas which give a 90-degree kind of a coverage. But imagine where you want to capture camera feed where cameras are spread all across. There you use omnidirectional antennas whose coverage length is less, but you get a more coverage angle. In that way, you can optimize your hardware. We have given all kinds of options to select the best hardware based upon their requirement. We have got a multi-hop mesh structure that I will explain in the subsequent slide. So, for example, the first step to realize such system is to carry out a network strength survey. For example, if you have a very good adequate network strength, then the data from the camera can be directly taken over to the necessary location using a GSM kind of architecture, like the same way we use in our mobiles using SIM cards. However, in case if necessary network coverage is not there, in that case you need the additional hardware like access points, backhaul clients, backhaul repeater layer, and finally a central hub receiver, which is basically located at a high tower, maybe 30-35 meters kind of a tower inside your complex. Now, here comes the multi-hub cluster mesh. Say, as you can see, multiple cameras are connected to access point, and multiple access points are clustered together to form a multi-hub mesh. This is important because it is not possible to have line of sight from all access point to the subsequent infrastructure. So the access points communicate amongst each other, and the data from the access points from which you have an actual line of sight will communicate data to the next layer. Now from that, I lost that. Okay. Now from that central station, you need that data to be analyzed. So once the data reaches the central base station, we pass the data through a firewall, and through a network switch, we carry out all kinds of data analytics on the data. We have got a video analytics server on which your AI algorithm is actually running. You have got a video management server with necessary failover. We have got storage, and we have also shown a workstation where a person can sit on premise and manage the overall system. Whichever violation videos are identified by the AI are transferred to the cloud server through that MPLS router with internet connectivity, and only relevant information regarding safety violations, like in the form of safety violation photos, short videos, etc., will be sent to the cloud server. So ladies and gentlemen, here my intention is not to load the internet connectivity with excessive data. Only the relevant data is sent to the cloud server for necessary storage. Over the cloud server, you have got a mobile-based app also. So for example, your HSE personnel are able to locate some kind of a safety violation which is not captured by the camera. Those can also be uploaded to the cloud server through the app. So we are giving you flexibility of using a digital system which comprises of an automated system as well as a manual system. Now coming over to the AI engine, while covering the AI engine, I must say that we have deployed a pre-trained AI model, because since we are also using this for construction safety monitoring, we don't have the leverage of many months for the model to develop. The model which we are implementing is about 90 to 92% pre-trained. So once implemented, within a very small span of time, you will be able to get necessary results. We have carried out optimization at this stage at 3 levels. One level is that server optimization by selective use case, a specific camera usage, depending on the location of deployment. For example, you have got safety violation in terms of height work, and the location which this camera is covering does not have any height, like everything is on ground. Do you need that particular use case? You don't. So for such cases, there is a possibility of optimization that the AI algorithm will not implement those algorithms for such kind of cases. Then we have got short on-premise video analytics with cloud-hosted violation detection and storage model that we have seen. And we have seen special rigs. We have a special rack-mounted air conditioning for these servers also, since they dissipate a lot of heat. Here I have just shown a hierarchy of the video analytics model which has been implemented. We have got cameras which are capturing the video. We have got identification that we have covered before, where the okay, here we have used innovation. There is a possibility of using use case specific triggers to analyze the video. That is, for example, you have got use cases like no motion detection or a person fall detection, but there is no person in your current video frame. In that case, you don't need to store that video. So the analytics itself, the storage is triggered by the presence of a person. So that way you optimize the server, and that has implication with respect to cost saving also. Then we have got storage at both levels. The videos which are captured from the camera for analytics are stored on premise. However, only the errors, the safety violation videos are sent to the higher level or cloud storage for further storage. That is covered in the transmission part. Now we come towards the end of the presentation. Here we are talking about the digital handshaking between various stakeholders. Here anointed images and short videos stored with unique identification numbers on cloud for 6 months. So whichever video has a violation video or it is a safety violation photo, we are associating with a unique number and the location where that violation has been detected. Now, owners, HSE personnel will access the cloud through like a password protected mechanism through their customized dashboard, and they will attach those videos and photos to generate a report. That report automatically goes to the safety personnel of the contractors or other agencies who are carrying out the violation. They also access the same cloud through again their own customized dashboard. So once they access that module, they give their response and compliance to that same module. And we have got a proper workflow through which this acceptance, rejections, and all those mechanisms are implemented. Now, one salient feature about this solution is automated alerts to emergency services with location for emergencies like fire, fall, etc. For example, you need first responders to respond to some situations like fire, or if at all the person has fallen from height. You don't have to go through this compliance process or any other mechanism. The software itself triggers customized messages and information to safety personnel like fire brigade, etc. to take response. So this is the final slide. Here we are trying to conclude the presentation. AI engine effectively identify defined HSE violations with minimal false positives. As I have explained before, the model is pre-trained to the maximum extent possible. Contractors can report improved closure rates for identified violations, while owner achieve near real-time insight into site safety status. So here, initially you have got cameras which act as eyes for your HSE personnel, but here we have got an AI algorithm which acts as a small brain along with the eyes. So it is not just you are having a look into the plant, you are also getting insights of what is happening with respect to safety violation. There is transmission of meaningful safety videos and clouds. As I have explained before, only meaningful information is sent, not all information. And it combines automated and manual safety inputs and provides comprehensive coverage for both structured and unstructured risks. Structured risks are those risks which are covered by the use cases. Unstructured risks are those risks which are identified by the safety personnel. So the system complements the safety personnel to collude together to implement a better digital safety monitoring system for the overall complex. Regarding questions, I have been informed the questions has to be taken at last. And I thank IEW for giving me this platform to present my work. I thank my HOD, HOD DTS Bhaval sir, along with whom I have worked. HOD Ritu ma'am, thanks for finding time to listen to my presentation. Thanks to the audience, moderator, jury. Thank you very much.
Thank you, Saurav. Thank you very much. We can just see how safety behaviors can be observed through video surveillance, and that analytics can help you in building the risk prediction, you can say. So I think risk prediction is something as AI will help us in future, but for that you have to build that data, and these cameras observing the safety behavior and safety violation will build that data for further modeling of risk predictions. I think that's where we can take it to the next level of risk prediction from these violations and from these safety behaviors, which gets accumulated over a period in the people's behavior, right?
That's correct.
I think like I can see it as a risk prediction in future.
That's
Thank you very much. We'll go on with the next presentation, Mr. Chandrasekhar, MD, AlphaMERS Limited.
Very good morning to all of you, fellow panelists, dear friends. I come from background of a merchant navy captain, oil tanker captain, a very operation person. And I remember as an officer on the ship, you go down clean tanks. And when you go down, you're going down 20 meters down. It's almost like a 7-floor building. You're going down. It's dark, greasy. And the ladder is not much of a fancy ladder. They are square rods welded. And in case you slip, you're going to get yourself hurt very badly. When you go down, when you look up, you can see almost like one of these overhead lights, a small spot of light from where you came in. And in case you're getting gassed out because of hydrogen sulfide, oxygen deficiency, or hydrocarbons, you still need enough energy to go back the 7 floors up to get out of that. That was the kind of risk you faced. And you could have these hazards anytime. coming to you. And it was that time then I thought this is a fit case for robotics. The human being should not be doing this. It should be robotics that should be doing that. But that was a couple of decades ago. And few years back, thanks to Oil India Limited, they said, okay, if you are able to make a robot, we'll support you. We'll help you with funds. Thanks to them, we got into this and we did exactly that. We made a robot that could go inside a crude oil tank, pump sludge out of the tank. I will show you that. That's the robot. One of our keen interest was, okay, I'll just hold on until this is over. Okay. I don't know how to stop that video. Let that go on. We were very keen that we should make the robot very low height, so it passes under the heating coils. We could manage to make it to 370 millimeter, and I had measured that time a couple of tanks, and we had a good 50 millimeter clearance from the heating coils. And one more thing we are very particular about is that we should have a pump on the robot. The reason why that's so important is the first generation robots around the world, there are very few of them, hardly maybe 4 or 5 such solutions. They use suction as an approach. They take a suction hose on a crawler inside, and of course they call that as a robot. And the suction has got a handicap. Suction is limited by nature to 1 bar. Between atmospheric pressure and vacuum, you have only 1 bar difference, and you and me cannot do anything about the atmospheric pressure or the vacuum. That's very less to pull thick sludge through long hoses. It's like trying to eat ice cream with a straw. You can pull as hard as you can, create whatever vacuum you like, but it's only the atmospheric pressure that's pushing the liquid from the other side, and it won't move. So we put a pump on it, and then we use the discharge pressure of the pump, which is 5 to 10 bar. Today we did 5 to 10 bar. It's technology. It will improve continuously. Somebody smarter than us would do probably 20 bar, whatever. But that was the way to go ahead with that. And then the sludge started coming out beautifully, as you could see in the video. So what we did in this robot was we used to sweep the sludge, crush it so that nothing in that is bigger than the tolerance of the pump. It crushes to less than the tolerance of the pump, feed it into the pump, and the pump pushes it out over a long distance. Now, these kind of robots have to push 50 meters, 80 meters. A typical tank dia can be 80 meters, and if you have to reach somewhere inside the tank, you need 50, 60 meters inside the tank and perhaps another 10, 15 meters outside the tank to reach to wherever you want to put the sludge with the hose. So to push that kind of, I think you have to also worry about the umbilicals. There is a certain, weight associated with hydraulic hoses. It's pulling long umbilicals. It's almost like a goods train with one engine and a lot of wagons. You may or may not get the traction inside the tank to pull such a long umbilicals. So we have boosters. When it becomes more than 25, 30 meters, we have boosters to pull the umbilical. We have boosters to push the sludge out further. Coming to ships tanks. Sooner or later, this technology is going to go on the ships. Ship is always very staffed, maybe just 25 people, and maybe 5 to 6 people do this tank cleaning. I remember myself, we used to load in Salomon in Scotland, go to east coast of US, discharge that. In 6 to 7 days, we used to reach Venezuela, Maracaibo Port, now become very famous for all the other reasons. We used to go there. In that passage, we used to clean 6 to 7 large tanks. And when we clean tanks, we are water washing, high pressure washing with fixed machines in the roof. And after that, gas spraying it. And typically, me or senior officer over there would be the person going down and cleaning all that. It used to be quite tiresome. And you always have a certain tension, underlying tension, that the person inside, you had to get him out in case he collapses because of any one of these reasons. And I still believe at the back of the hand, in real life, when you have an emergency, it doesn't go like a drill. People are at perhaps 30% of the efficiency in the panic mode, and it's not easy. So you always wish that people go down on their own 2 feet and come up on their own 2 feet. Now, coming to the robotic part of it, what was happening so far was that the crew would shovel the sludge into strong plastic bags, and it would be lifted with pneumatic winches 20 meters high, kept on the deck, and until a barge comes and takes it away. So today, it's all the more reason that you need a pump over there to give you at least 5 bar discharge pressure, so that it can climb up the 20 meters. The sludge can go up the 20 meters out of the tank. A suction cannot even lift more than 10 meters of fresh water in a column. So those first generation robots are out of question. We went on to make another robot, that is, we were told about this problem that this retail outlet, petrol pumps, they are spread out geographically in a large area, and there's no competence in those remote areas or no training for people to go in safely to these tanks if they have to inspect, if they suspect a leak or whatever may be the reason to go inside those tanks. So we made one more robot that when you fold the arms, it is very axially, it is very small, it will go inside a 24-inch manhole. And once it goes inside, it will open the arms, water wash the insides. It has 3 motion. It will lift up the arms, open the arms, the entire robot will go front and back. And with those motion, you can touch every inch of the inside of the tank. And you're continuously stripping the washings out. It has got jets all over. It has got on the arms. It has got in front of it. And it's got under the robot also. So you're able to remove all that washings out. So you don't have to now leave the tank open for a couple of days for it to vent out and then be safe for entry. You wash it for about half an hour or 1 hour. You remove the hydrocarbons from the sides, and after that you gas free for another 1 hour. In 2 hours you'll get the tank. You can enter it fairly safely. Okay. Let me go to the next slide and come back to this. Sorry. Here you can see in the bottom left is a distillate tank with polymers. Somebody had asked us saying that, can you please come and check whether you can do something about it? And these trays are in such a way that you don't have one straight passage from top. The trays are not overlapping, but they're almost in line. The edges are in one line, and you have to actually lie down and then move from one tray to the other. It's quite a difficult task for a human being to do that. And that is where we came up with the concept of a snake head robot. We just call it snake head because intuitively a hanging robot can turn this side like a snake's head, and you lower it and you turn it the other side, lower it further, and keep doing that until it can reach where. That is the robotic platform, and that the head could be just washing at that level. So I think another 2 months or 3 months, we should be able to do that. Pneumatically, we have done it, but pneumatic doesn't have the force to lift up 30-40 kgs of the head. So we'll be doing with hydraulics, the same principle. So this is why the image is there. We believe very much in biomimicry. One of the best designed machines is a human being. The way our hand, the way our fingers move about, we yet is some time away when we can make a machine that can feel the temperature, the texture, and the information that my finger can touch without me seeing, and that goes into the head. What are the temperature, what is the texture, how soft it is. It's simply amazing. So we look at these. When I was initially making the robot, I had in mind that I have to make it very small so that it goes under the heating coils. But if I am not successful in making that, I have to make something that jumps over the heating coils. And the image that comes to the mind is a 6-legged dog, a dog with 6 legs so it doesn't topple and it goes. Or a centipede for the matter. If you can imagine it, you can configure it. So we normally talk to people, then they tell us the pain points, and then we start working on these pain points, whether we can solve them. So in the bottom, you can see is a foundry, blast furnace. And one of the big companies in mining, and they have blast furnaces, and they called us and said, can you please see whether you can do something? And I went over there. It's actually quite sad to see 70, 80 degrees centigrade, the radiated heat, and people are standing there. They rush in, they have got an insulated coat, they rush in and do the tending the runner or whatever is the jobs, and they rush back. It's a difficult place to work on. So we are making a robot for them, which basically the essence of the whole robot is that it's self-cooling. Continuously the cooling is happening, and that's the whole gist of it. The motions are to do what the person is doing. So when we follow the biomimicry, one of the first things we ask is, how are you cleaning it today? Somebody told us, okay, we have got a tank where we have 2 inches of bitumen left over there, and how do you do that? How do you clean? What is your attempt? They said, okay, a person goes inside and is drilling. We know it's a very slow process of drilling, but I said, okay, hang on, if that works, we will make a robot that carries 50 drill heads inside and does 50 bits is drilling at one time until we come up with a better way to deal with it. Municipality chief engineers have contacted me and they've asked us for solutions which we have developed, which I think in another month or so we might be launching it, is to remove silt underwater. You can see in the bottom, there are places like this where the houses are both sides. The only answer municipalities have is Hitachis. Hitachi goes into the stormwater drains and they pick up one bucket at a time. And you can see when there are houses on both sides, the bottom right image, they have to go 50 meters with every bucket to throw it somewhere. So they have their handicaps. And on the top, the photograph is under the culvert, the Hitachi don't go. It cannot go. So you are having silt continuously getting built up. And when you have a day with a heavy rain, that is testing your system because the aperture is reduced now and the water is not able to flow, and you have a flooding chance there. So this robot that we have made is a tethered, submersible, amphibious robot. It can cross the road on its own and then it can get into the water, and it can submerge when required. It's all remote controlled, tethered. There's nothing autonomous about it. And it will go inside, and in this case, it is dealing with silt, removing the silt over there. But the same robotic platform we plan to use for ponds where there's a sludge which is settling down. I believe a lot of reservoirs have this problem. You're having pond in which the sludge is settling down, except that the payload will be different. That is easier. The sludge is pumpable. Even if it is highly viscous, it is still pumpable. Unlike the silt, which is abrasive, which is not very friendly for pumping. We need specialized conveyors for that. But we intend to use the same platform for the other application. And I would invite all of you, whatever is your pain point, where you think human should be removed from that scene, eliminated presence of human being, please discuss the pain points with us. We will seek your help, and then we will quite possibly we'll be able to develop solutions, and with your help we'll be able to do the trials. We normally do this in our facility in Bangalore after extensive trials, then take it to the site into the site conditions. Thank you very much.
Thank you. Thank you, Mr. Chandrasekhar. I think it's a very good insight on how human interventions can be reduced wherever there are high risk activities. Like confined space is always our challenging area where we try to build some special permit to work systems to mitigate those risks. But this type of drone, bringing them will definitely reduce our risk. Hazard elimination is biggest opportunity I can see it here. Thank you very much.
Thank you.
Thank you. We'll go with our next presentation by Dr. Abhinav Bhandari, Senior Manager, IndianOil Corporation. He's having around 19 years experience in oil and gas. Thank you. Please.
Good morning, eminent speakers on the dais, my seniors and delegates of the conference. Here I am presenting an IndianOil Mathura refinery initiative on circular water economy by reusing the treated municipal effluent of Mathura, ensuring an social, economic governance through sustainable efforts of IOC. I'll come back to this slide again. Please. The Ramuna River around Mathura holds a very religious and cultural importance in the Mathura-Vrindavan region. However, in the stark contrast, it is exposed to severe environmental degradation where the river quality has degraded to a significant ecological and public health affecting the lives of a common as well as aquatic. The case study here addresses the dual crisis which encompasses both severe environmental pollution and acute industrial water vulnerability. The prime source of degradation in the high urban area in Mathura alone generating around 67 MLD of partially or untreated treated sewage water. Down the Rhine stream from the Delhi, the river is pushed to an ecological contaminants as well as where the biological oxygen demands and the dissolved oxygen level has gone down drastically. Speaking of the figures, biological oxygen demand came down as low as 25 to 30 milligram per liter from a standard of 3 milligram per liter, and dissolved oxygen dropped down below the 2 milligram level relative, suggesting that it is insignificant to sustain life for the aquatic purpose. Looking at this precarious situation, Yamuna required a systematic solution rooted in the principles of circular economy. An integrated approach was conceptualized, treating urban wastewater and meeting the industrial water demand, especially to the refinery. This initiative represents a fundamental shift from our past of linear model where we use the water, treat, and then dispose it back into the refinery. We call it as take, use, dispose. Then to shift towards a circular path, circular economy, where we tend to treat, reuse, and restore, setting in measurable improvement both industry and to the environment. Thus, the project was a joint participation from NMCG, National Mission for Clean Ganga, UP Jal Nigam, and Indian Oil Mathura Refinery to treat the effluent wastewater of Mathura with a plant built in support from NMCG and UP Jal Nigam of 20 MLD, offering a blueprint to a circle economy and supplying the treated water to the Indian Oil Mathura Refinery. The project originally grounded from the Government of India Clean Ganga Mission, launched in 2014, where the pollution to be addressed to the Ganga and its tributaries and especially to the Yamuna River. The initiative gained momentum after a high deliberation meeting from the ministerial to the Mathura promoting the reuse of treated wastewater for non-potable purposes, for which MOU was signed between IOCL and National Mission for Clean Ganga on August 16 for direct using the STP water for non-potable purposes. National Mission for Clean Ganga was the sole stakeholder where the primary funding was provided by them. UP Jal Nigam was the main stakeholder for providing and selecting the private operator. Indian Oil Corporation, Mathura Refinery was the industrial end user where the guaranteed demand of treating water was signed. Currently, around 4 MLD of treated sewage water is being supplied to Indian Oil Mathura Refinery, and another 15 MLD plant has been completed by Messrs. Welspun Smart Ops and is expected to commission by the mid of this year. The project financial structure is broken down in the form that a capital investment of around rupees 437.95 crores was funded by NMCG, and to project special purpose vehicle, that is the private operator Messrs. Triveni, who has built this plant. IOCL financial commitment over a 15 years term agreement is paying around rupees 42.38 crores towards operation, maintenance, electricity charges, and a water tariff of rupees 8.70 per kiloliter. The complete economy can be summarized. The water economics making this sustainability target where the base water was rupees 8.70 per KL, and the total effective cost will be 16.4 millicube for a 20 MLD plant, and currently since 4 MLD is being provided, it's rupees 27 per meter cube. The value proposition is the reliability that is being sought, reliability in terms that a continuous water supply, irrespective of what the monsoon season or the peak summer, there will be a supply of continuous water of 20 MLD to Mathura refinery. Sustainability, that the fresh water consumption will go down as low as 50%, that is being currently taken from the Yamuna river, and that will be supplied to the agriculture and the domestic purposes, and predictability in the terms that a 15-year settlement is being taken. So I am ensuring that the refinery water resources are not compromised in any way. This financial success was a long-term viability through public-private partnership under hybrid annuity model. The HEM splits the financial risk and provides a powerful incentive for both the private players and the asset performing for the entire life. The HEM ensures the private player that the KPIs, including the quality as well as the quantity, being supplied during the operation and with the minimum downtime. Again, the investment model of reliability and sustainability, predictability. The advanced technology used in the project is three-stage step, a primary and the secondary. The primary is mainly related with the removal of solid heavy metals, heavy objects, and the grit from the raw water. The secondary treatment includes the sequencing bed reactor, where the microorganisms consume most of the organic pollutants. Tertiary treatment was incorporated into the system, mainly to bring the quality of the water to the refinery requirements, wherein the microbioreactor as well as ultrafiltration technique was incorporated. The final polishing and the disinfection is done through chlorination, through the chlorination, ultraviolet, and ozonation. Finally, this industrial grade water is transferred from the site through a 9-kilometer pipeline to the refinery, where it is used in various processes. So the transformation of quality from a sewage to industrial asset. As we can see, the detailed technical comparison of STP effluent quality versus the IOCL feed water requirement. You can see that the IOCL requirement is very much stringent, primarily because of the feeding in boiler, cooling system, steam generation, and other water applications. I'll come back to this slide again. As you can see, the tertiary treated water achieved is much, much better than the CPCB standards for reuse. Even beyond this tertiary treated achievement, the refinery goes on further to polish down and bring down the quality much to the requirement of IOCL side. But what the major aspect to this phenomena is that the water quality from the sewage has brought down to a very good level of CPCB standards, which was possible only by using of the smart advanced technologies. No. Going back to the previous, the requirement of IOCL stringent for the water quality is mainly because that these impurities leads to either scaling, corrosion, fouling, either due to the presence of metals or to the presence of your hardness, silica. So before feeding into the processes, further polishing is done in the refinery premises. Okay. Post inception of this project, major rejuvenation of Yamuna river was observed. especially in the two critical parameters of biological oxygen demand and dissolved oxygen. Biological oxygen level almost around 20 million liters of untreated sewage water was prevented from getting into the river, Yamuna river, from the Mathura region, which are approximately prevented around 800 to 1,000 tons of BOD from contaminating the river ecosystem. The project led to the fall of around BOD level to 8 to 18 milligram per liter against the initial of 25 to 30 milligram per liter. And the dissolved oxygen level came well above 2 to 5 milligram per liter, which was previously less than 2 milligram per liter. Therefore, creating a sense of returning the aquatic life back to the normalcy. Enhancing the water security was the main prime focus of this particular project, where around 20 million liters of wastewater per day was saved, which also prevented a freshwater intake of around 6.0 million cubic meters to the Mathura refinery from the riverbed. This massive volume is now available for the region's domestic and agriculture purposes. Industry not only shifted well beyond the limit of fresh water and sustained a recovery level of around 25 to 30, where the total fresh water consumption was decreased in the refinery. Sanitation improvement was observed around the area where the potholes, open drains were significantly brought down. Waterborne diseases was observed brought down and improved the conditions of the livelihoods. Looking at this particular aspect, the NMCG was of the opinion that it's a blueprint for Indian system where around 72,368 million liters MLD is being brought to the sewage. This is a massive amount that India is generating, and around 28% of which is getting treated up, around 20,263 MLD, which is very less looking at the vast volume of sewage that is being generated across the country. The NMCG is in the opinion of bringing down and capturing this sewage treated to occupy all the current availability of the MLD of sewage being generated in India, for which around 29 new plants around Ganga Basin is being brought to the project level. Furthermore, the blueprint of this Mathura refinery, taking the sewage water and bringing to the industrial asset quality. IndianOil Panipat refinery is also now implementing a similar water use model. Areas like Chennai, Surat, Nagpur, Vadodara are also integrating their municipal systems to industrial clusters and to bring out the system for rejuvenating the ecosystem. Yes, sir. Sorry. The water is circular. So the conventional model of take, use, dispose is now being fundamentally changing into the treat, reuse and restore, bringing down the ecosystem back to its life. This IndianOil Corporation Mathura Refinery stands as a premier example of a circular economy where a unique success story is a replicable, scalable, a blueprint, and can be collectively brought to a sustainable level where the environment challenge can be changed into a multifaceted opportunity. This not only brings the Mathura Refinery for the measuring of its environment sustainability, it also complies with the ESG norms as well as the United Nations Sustainable Development Goal Clean Water Sanitation Program. Thank you.
Thank you, Abhinav.
Thank you.
I think it's encouraging to see IOCL doing such great work for societal cause, and at the same time creating win-win situation for the corporates. Means it's one is you are helping the society to clean river and get a good quality water, and at the same time you are helping your organization also to create a win-win situation. It's really great. Thank you very much. Mr. Harvey Johnstone, Environmental and Asia Pacific Director, is having around 34 years of experience in environment management.
Thank you. So thanks to my previous speakers, and thank you all for coming this afternoon. That last presentation is a good segue into what I'm going to talk about today. What we've just seen is the circular use of water, which reduces water stress. And what I want to talk about is implementing a no net loss or net gain in the oil and gas sector, specifically around biodiversity. And our organisation is the International Association of Oil and Gas Producers, and we've produced a guideline on how do you get to a point of no net loss and net gain. So, why would we think this is an issue? Well, it's actually a business issue, and it's not some abstract, intangible environmental concept. And from a technical standpoint, biodiversity risk translates into both operational and regulatory exposure, but also financial exposure on top of that. So if we look at ecosystem service degradation through land use, disturbance, resource extraction, these can all affect things like water scarcity, erosion control, and climate regulation. And all of these have quantifiable operational dependencies of the plants that we operate. So the impacts of our industry are pretty well characterized. We have habitat conversion, fragmentation, we have species disturbance, invasive species pathways and introduction of invasive species, and of course we have pollution. Now, the dependencies of a site, these can all include things like hydrological regulation, sediment stabilization, and natural hazard mitigation. So where the environment's actually used to mitigate, to regulate all of those issues. And these can be quantified using ecosystem service models such as INVEST and ARIES, and then you can integrate those model outputs into the risk register. And that's why biodiversity is increasingly treated as a material environmental social governance factor by many corporations when it comes to operating around the world. So how did this all come about? Well, there's a very fast-moving and decisive shifting global policy landscape. So if we look at the Kunming-Montreal Global Biodiversity Framework, which was established about 2 years ago, this sets a clear mission, and that's to halt and reverse biodiversity loss by 2030. And to do that, it's established a 2020 reference baseline and a 2030 recovery trajectory. So what it wants to do is get back to the 2020 baseline by 2030. And target 15 of the Global Biodiversity Framework specifically talks to business, and it asks business to assess, disclose, and reduce biodiversity impacts using scientifically robust metrics, and not use narrative descriptions or feel-good factors around biodiversity. So nature positive is not a project level requirement, it's actually a global outcome according to the GBF. And what we think is that no net loss and net gain is a site level contribution to that. And to be that, it's got to be measurable, time-bound, and aligned with national biodiversity strategies wherever those operations are. So here we are into the mitigation hierarchy on this particular chart. And this is the foundation of a credible biodiversity outcome. If we look at avoidance and minimization on the left-hand side of that graph, they're the most reliable and cost-effective steps. And the guidance emphasizes that without strong early mitigation, no net loss and net gain may simply not be feasible in the process. So then we go to restoration and offsetting, which is the blue and the green in there. And these carry a whole lot more uncertainty and cost to them. So they should only be used once all reasonable avoidance and minimization have been exhausted in the early stages of the process. So if you look at this mitigation hierarchy, technically you'd look at it as a risk minimization algorithm. It's where avoidance reduces uncertainty because you're avoiding impacts which require no restoration or offsetting. Minimization reduces the magnitude and duration of impacts, which will thereby lower the offset ratios required after. Restoration, however, introduces ecological uncertainty. And so success probabilities of restoration have got to be modeled using either reference ecosystems and time lag multipliers, which is the effect of time it takes to restore and offset. And then finally, offsets, the last one there. These require equivalency analyses, additionality tests, long-term governance mechanisms. So this is why early stage avoidance is the most cost-effective and defensible path forward. So when is it appropriate? So it isn't required, it's not even appropriate sometimes for every project. And some of the drivers that might take you down this path include regulatory requirements, depending on the jurisdiction you're in, lender standards like the International Finance Corporation's Performance Standard 6, and a company's own corporate ESG commitments, which they would be bound by. But probably most importantly is stakeholder expectations. And these matter a lot because this really matters when you have biodiversity having a cultural significance, or indeed it factors into a livelihood significance, so that there are people who actually live off this habitat and biodiversity. Now, what our guidance will say is that there are some upper limits here and they simply can't be offset. So no net loss and net gain might not be feasible. But what would feasibility depend on? Well, we'd need to look at the impact significance. We'd need to do that using sensitivity magnitude matrices, or indeed the International Finance Corporation's own Performance Standard 6 critical habitat criteria. We'd need to consider the offsetability. So is the biodiversity feature irreplaceable? What's its vulnerability? And what's the feasibility of being able to restore this? We'd need to look at availability of like for like or better for offset. So you can't remove 10 hectares of mangrove and try and offset that with 10 hectares of pine forest. We also need to look at time lag and uncertainty multipliers, and I'll talk more about those shortly. But then finally, of course, we need to look at what are the stakeholder acceptance thresholds. What is it that the stakeholders are actually prepared to accept in this process? So the guidance will emphasise that some of the impacts that are going to be occurring through some of the activities that we do, such as loss of irreplaceable ecosystems or critical habitat for highly threatened species, these just aren't offsettable at any ratio at all. So this is the backbone of the guidance framework. There are 8 steps. Now these can be applied across the life cycle of a project. You can start at early screening, or you can go through to post-closure and legacy sites. So it's flexible enough for greenfield developments, for brownfield operations or legacy assets, and it aligns with best practice and disclosure frameworks. So the steps are iterative. That's why there's a circle there. It's not a linear process. And the reason is because ecological data changes over time. And for example, a baseline might be redefined as new species detections occur, or remote sensing improves habitat classification. So when you get more information, you've then got to update your impact assessments. And as the project evolves, you also need to update the impact assessment in the process. Then monitoring results will feed back into adaptive management. You'd need to look at adjusting restoration trajectories or offset management actions. So we think this structure gives companies a clear pathway to deliver measurable biodiversity outcomes, but it also helps you maintain operational feasibility in the process. So it is designed to be auditable and compatible with biodiversity accounting systems, and each of the steps corresponds to a specific data requirement. So for example, if we're looking at baseline, we'd be looking at things like spatial and ecological data sets. For impact assessment, we'd be using quantification models. For targets, that's important around getting the right metrics selected. And then for offsetting, we need to look at equivalency logic. So let me step through briefly the 8 steps that we've got there. So firstly, a robust baseline is essential. So using tools like IBAT, remote sensing and field surveys, we need to identify what the priority biodiversity features are. So they've got to include things like habitat condition, species presence and absence, functional attributes of the biodiversity feature and ecosystem processes. So legacy sites, where you're looking backwards, these may require retrospective baselines using historical imagery, reference ecosystems or counterfactual modelling, where you remove the stressor and you model backwards to determine what would have been if you weren't there. The second one is impact assessment. So these must consider both all 3 direct, indirect and cumulative effects, and they've got to apply precaution where significant uncertainty exists. So residual impacts can be quantified using standard metrics such as habitat hectares, biodiversity units or species abundancy indices. And uncertainty's got to be explicitly modelled using precautionary multipliers. Step 3 is setting SMART targets, which is specific, measurable, achievable, relevant, and time-bound. So SMART targets ensure clarity and accountability in the process. And they've got to specify the biodiversity feature that you're looking at, the metric you're applying to it, its spatial boundary, and the time frame that you're looking to actually get no net loss or net gain in the process. And they should be linked to an ecological recovery trajectory. The fourth step is around offsetting, and this includes MACAs and ACAs. So a MACA is a measurable additional conservation action, and an ACA is just an additional conservation action. So these have got to be used carefully with clear distinctions between what a measurable gain is versus what a broader positive action might be. So for offsetting, these require additionality tests. That is that biodiversity gain is offset above and beyond what would have happened without the offset. It needs a permanence mechanism, which means that you need to deliver the gain for at least as long as the project impacts last. And you need to use equivalency analysis, so the offsetting needs to be like for like or better. You need to use time lag and uncertainty multipliers, because offsets do take time to mature and there's no uncertainty attached to ecological restoration. So you need to inflate the amount of offsetting required to achieve what you would as a minimum. And then MACAs are generally measurable gains, but these aren't tied to specific residual project impacts. And ACAs are where you generate a biodiversity benefit, but they can't be counted towards no net loss or net gain. And an example I might use there is a biodiversity education program in a community or in schools in the location. So the last 4 parts of the 8 steps, the biodiversity action plan. So this is essentially a single operational document where everything comes together. It's got to integrate the mitigation measures, offset design and governance, monitoring indicators, and of course, stakeholder engagement. Then when it comes to implementation, this is going to require cross-functional teams and internal capacity, so you need to resource it adequately. You need roles, responsibilities, and budget allocations outlined and early action to reduce any uncertainty around the process. So this needs to integrate with environmental management systems, financial planning, and also contingency measures. For monitoring, this has got to include compliance monitoring, so were the actions actually implemented? Effectiveness monitoring, so did the biodiversity respond as predicted in the process? And disturbance monitoring, which is where you actually quantify the losses of habitat or biodiversity. And then finally, reporting. This needs to align with the TNFD's recommended disclosures, which is around metrics, targets, governance, and risk management. So finally, a couple of key takeaways here. No net loss and net gain are achievable with early planning and strong baselines. The baselines are robust and include condition, function, and species data, and residual impacts are quantified using defensible metrics. Offsets are a last resort. Avoidance and minimisation matter most. Offsets must meet equivalency, additionality, and permanence criteria. MACAs and ACAs offset flexible pathways for biodiversity enhancement might not always be able to be used for no net loss or net gain, and monitoring needs to be statistically rigorous and linked to adaptive management. So we think this approach strengthens regulatory compliance, reduces project risk, and contributes to national and global biodiversity goals. So that's all. Thank you.
Thank you. Thank you, Harvey, for guiding us through the steps of biodiversity. Thank you very much. That brings us to the end of this session on technological advancement in HSSE. Thank you all the speakers for presenting your use cases and enhance our safety practices. Thank you very much.